Today we're going to go over how to use the Unpack feature for PHP. It's effectively a function that takes in a string format and some data, some hacked data. Now, the understanding of pack and unpack basically means the organization of bytes. And there's two major ways bytes can be organized, little endian and big endian. Effectively, one's reversed and the other is not. One's used for networking, the other is mostly used for file system stuff. I really don't want to go into too much, but I just want to go over how to basically read in binary information. So here's an example of a bitmap, a penguin image, and we're going to read in the header type and the file size. So Wikipedia gives this nice little image of the breakdown of the header between a bitmap and a DIB header, and this goes a little bit more in depth, saying that everything, all integers are stored in little endian format, which I just brought up, and so this is important to know. The other thing that's going to be important to know is the number of bits in a byte, because when you're reading the pack documentation, it's going to talk about bits, not bytes. So 1 byte is 8 bits, 2 bytes is 16 bits. So here we have an example saying that the first 2 bytes is going to be the identifier of the bitmap, and it'll be 42 4D. So I've already written up some PHP code, so you're not having to watch me type this stuff out. And effectively, I just get the data in memory, and then I start to read the header with some funky looking sequence of characters. And to break this down, effectively, the first letter between each slash, each delimiter, is going to be the type of byte. Now you can subsequent this with a number, so you can say like 4, and then you're just saying, okay, the first 4 of this identifier is going to be read into the key of signature. Now, where am I getting this V? Well, I'm getting it from the pack function. So pack says V is an unsigned short 16 bits little endian, which is actually what we need. It's 2 bytes. And I'm kind of guessing here for unsigned and signed, but it doesn't, you'll figure out quickly whether it is or is not. I didn't see the documentation saying everything was unsigned, but what I've seen worked. So let's just go ahead and I'll put this out so you can understand what I'm talking about when I say key. So we look at signature. Well, that was actually what I typed here, signature. So it's just saying like, okay, file size is mapped to the big V. The big V is this number, width and height, and image byte index. All these are coming out as an array that you're going to get the information into. Now this could be numbers, it could be strings. And so the first part, though, the signature, is a number. It's not what they talked about. It's not 42 4D. Well, how do we do that? You can look into the pack documentation. It talks about hex string. Well, it's actually what we need. Well, is it low nibble first or is it high nibble first? So let's try that. Let's try H and signature. So if we run that through, we get 2. Well, okay, that's not what I actually wanted. I wanted 4 letters and numbers. Well, that was because we forgot to put the number of whatever this indicator was. So let's run it through one more time. And now we actually get 4 hexadecimal numbers and letters. But hey, it's reversed. It has all the numbers. It has 4 and 2 and D, but it's not in, like, it's all reversed. Well, that's because we use low nibble first, and in this situation, we're going to not want to use the actual high nibble first. So if we take it with the capital H instead, and we run this one more time, we then get 42 4D, which is actually the format that we need it to get to identify whether or not this is a bitmap or a DIB header. The next part to this that I just want to quickly touch on is the uppercase V and where I got that from. So if you go back to the pack documentation, you see that the big V is 32 bits, which is 4 bytes, and a little Indian, and it's unsigned. Now, I didn't really go over this between signed and unsigned, but basically a signed integer is a negative and positive number. An unsigned integer will always be a positive number. And you might have seen this before. You'll see like a negative 127 to 127 as a range, or 0 to 255. Well, 0 to 255 is an unsigned integer, and specifically an unsigned byte, or a char in this instance. So if you were to use the big C, you'd get a maximum number range of 255. And so here we're using the file size. We compare it against the actual file size of the picture, and then I echo out if it does match. So if we look down here, we see file size does match. So I can use the unpack feature, actually read in a bitmap, and if I wanted to, all the pixels in it, and get the file size that's related to this bitmap. So I hope this was useful. I hope you've learned something about the fundamentals of bytes and how they can be organized and identified. And hopefully this will help you read in either a new protocol or a new binary format that you've come up with. Now, just to be clear, what I'm doing here isn't new. I mean, there's plenty of solutions and libraries out there to read in binary information from bitmap and parse the bitmap and write a bitmap. I don't recommend you guys writing this stuff out. Always look for this stuff first before writing it. But if you come up with your own format or something like that, then this is certainly recommended.